Here we will see division of arrays in Numpy. We can perform division on two arrays with different methods in Numpy. First is standard division operator, then integer division operator, then numpy.divide function and division by scalar value. We can perform division on two array with division operator. This performs element-wise true division, which results in floating point numbers even if the inputs are integer. General syntax is array1 divided by array2, where array1 and array2 are required parameters which specifies the arrays. If array1.shape is not equal to array2.shape, then it must be broadcastable to a common shape. For example, here we have imported the numpy as np and we have defined two array1 and array2. Array1 is declared with np.array and elements as 10, 20, 30, 40 and 50, and array2 is declared as np.array with elements 3, 4, 5, 6, 7. And when we give result 1 equal to array1 divided by array2, it will give element wise division. That is 10 is divided by 3 and it will give the output as 3.3333. 20 is divided by 4 and it will give the output 5, 30 is divided by 5 and it will give the output 6, and so on. We can also perform the division on two arrays with integer division operator. This also performs element-wise integer division, but it truncates any fractional part and returns only integers. General syntax is array1 with integer division operator by array2, where array1 and array2 are required parameters which specifies the arrays. If array1.shape is not equal to array2.shape, then they must be broadcastable to a common shape. For example, first we have imported the numpy as np, then we have declared the array1 as np.array with elements 10, 20, 30, 40 and 50, and we have defined array2 with np.array and elements as 3, 4, 5, 6, 7, and when we give result 1 equal to array1 integer division array2, it will give the output as 3, 5, 6, 6, 7. Here it will divide 10 by 3 and it will give integer output as 3. Then we will see performing division with divide function. For this, general syntax is numpy.divide with parameters array1, array2 and out, where array1 and array2 are required parameters which specifies the arrays. If array1.shape is not equal to array2.shape, they must be broadcastable to a common shape. And out is an optional parameter which specifies a location into which the result is stored. If it provided, it must have a shape that the input broadcasts to. If it is not provided or none, a freshly allocated array is returned. For example, here first we have imported the numpy as np, then we have defined the array as array1 equal to np.array with elements 10, 20, 30, 40 and 50, and array2 with elements 3, 4, 5, 6, 7, and when we give result 1 equal to np.divide array1 comma array2, it will print the result with fractional part. All these methods suppose dividing a numpy array by a scalar value, which will perform the operation element wise on every element of the array. This performs element wise true division, which results in floating point numbers even if the inputs are integer. General syntax is array1 divided by scalar value, where array1 is a required parameter which specifies the array, and scalar value is also required parameter which specifies the value for division. For example, first we have imported the numpy as np and we have declared an array with elements 10, 20, 30, 40 and 15, and we will assign value equal to 2. And when we give result 1 equal to array1 divided by value, it will give the result as 5, 10, 15, 20 and 7.5. That is, it will divide 10 by 2 which will return 5, 20 by 2 which will return 10, and so on. If we give result 1 equal to array1 integer division value, it will give the output as 5, 10, 15, 20 and 7. That is, it will return only integer value. And if we give result equal to np.divide array1 comma value, it will give the output as 5, 10, 15, 20 and 7.5. Then we will perform this array division in Jupyter Notebook. First we will import the numpy. So import numpy as np. Then first we will define array1 with np.array with elements 10, 20, 30, 40, 50, and we will define another array as array2 equal to np.array with elements 3, 4, 5, 6, 7. Then first we will perform division with division operator. So result equal to array1 divided by array2, and we will print the result as division with division operator and will print result. And when we execute, it will divide the elements of array 1 with array 2. Then we'll see division with integer division. Then we'll see result equal to array 1 integer division array 2, and we'll print division with integer division operator. We will print result, and when we execute, it will give the output as 35667. That is, it will return the integer values even though the output is floating point. Then we'll see division with divide function. So result equal to np dot divide array 1 comma array 2, and we'll print division with divide function, and we'll print result, and we print result, and when we execute, it will give the output with floating point numbers. And then we'll see division with scalar value. Here I will assign a value equal to 4, and we'll see result equal to array 1 divided by value, and we'll print division with scalar value comma result, and when we execute, it will give the output as 2.5, 5, 7.5, 10 and 12.5. That is, it will divide each element of array by 4, and it will generate the output as 2.5, 5.7.5, 10 and 12.5. If we use it with integer division, and I will do it with np.divide function, and if we execute, with integer division operator, it will return integer values, and with division operator and with divide function, it will return floating point values.